In the previous example, we solved this problem using nodal analysis. It was a relatively simple case with one equation, one unknown, but I would also like to solve this using source conversions and try to simplify the circuit as much as possible. So for this, what I will do is simplify parts of the circuit as much as possible. So this component here that we are seeing is in series with a current supply. So we can completely ignore this part, and then we can say that this whole circuit is actually equivalent to just having a 4 milliamp supply. And on this side, we have a 6 milliamp supply, which is now parallel to it. So we can redraw these guys as a 10 milliamp supply feeding to this particular node. If we were to complete the rest of the circuit, you can draw it like this. Kilo ohms. And when you're doing source conversions, you always have to keep in mind what the question is. You cannot disconnect that branch or convert it, because everything gets very confusing at that point. You cannot lose the question. So the question is asking for Ix, and I want to do one more source conversion. The problem I'm facing here is I cannot do a source conversion on my current supply because my current supply doesn't really have a parallel resistor to it. It has this three-way connection here. And my voltage supply also is connected in this junction to two different branches. So what I will try to do is use again a trick. I will add a 2-volt supply here, which does not change my circuit at all. And I will cut the line that is connecting these two supplies. So if you think about this, if I have the bottom of this as my reference, this node still is 2 volts. This makes this node 2 volts. If this voltage did not change, the current that runs through these two resistors don't change. Hence, Ix doesn't change. And since this is 2 volts still, what happens in this resistor doesn't change either. What is the advantage of this? The advantage is now I can do a source conversion on this particular combination and try to simplify my circuit. So if I do a source conversion for those, what do I get? I get a current supply with a parallel resistor. So what is the current supply value for this combination? Parallel resistor is going to be 3 kilo ohms, and 3 kilo ohms times whatever my current supply value is supposed to give me 2 volts. So I have 2/3 milliamps. I can redraw the rest of my circuit. Now you have to keep in mind how the connections are. Don't get confused with those. Now the bottom of this is connected to here, which I had also shown it as a reference. And the top part of this connection is connected up here. Now this 10 milliamp current supply is going from the bottom reference node to this node. And this combination also comes from the bottom reference to the same node. So it turns out that now I have a current supply resistor combination in parallel to my other current supply. So in other words, what I can do is I can redraw my circuit here, 3 kilo ohms and 2/3 milliamps, and erase what I had drawn on the other side, and I still have the same equivalent circuit. Now it's easier to visualize this. Now I have a 10 milliamp and a 2/3 milliamp current supplies that are parallel to each other. I can combine those two to a single current supply. So these two give me a current supply value of 10 milliamps plus 2 milliamps over 3. That makes 32/3 milliamps. And I still have a 3 kilo ohm parallel resistor disconnected between those 2 points. Can draw the rest of the circuit, 10 milliamps. Two volts here, 2 kilo ohms here. Now in this configuration, I again have, oops, what did I do? I had already combined these guys, so this is not there anymore. Now I have a current supply and a resistor combination that I can convert back to a voltage supply and a series resistor. The series resistor value is still 3 kilo ohms, that does not change. And the voltage supply value is going to be what? 32 volts. And I still have my 2 kilo ohms, 2 kilo ohms, and 2 volts. Now don't forget the question. The question is asking for this IX. So what we can do at this point is again do one more simplification. We can combine these. This gives us 5 kilo ohms, and then we have a 5 kilo ohm 32 volt. We can convert it back to a current supply and a parallel resistor combination. Let's make current supply, parallel resistor. This is 5 kilo ohms. Now I have a 2 kilo ohm that becomes parallel to that, and I have a 2 volt supply. Need to know what is the current supply value. 5 kilo ohms times the current supply value is supposed to give me 32 volts. So this is 32/5 milliamps. And if I were to combine these two guys again, these two resistors again, I have a combination of 2 kilo ohm parallel to 5 kilo ohm. So I have 1/Req equals to 1/2 kilo ohms plus 1/5 kilo ohms. Multiply this with 5, this with 2, ends up becoming 5/7/10 kilo ohms. So the equivalent resistance that I have here is 10 kilo ohms over 7. So if we were to Again, don't forget the question here. This Ix. We go back to a water supply and a series resistor. One more time. One last time, hopefully. We have a situation like this. Again, this is our question. Ix. The resistor value is 10 kilo ohms over 7. And then the water supply value is going to be what? We have to multiply 10 kilo ohms divided by 7 with 32 divided by 5. That gets us 64 over 7. So in order to calculate Ix, you can assume that this is your reference. That will make this 2 volts, and this makes it 64 over 7 volts. Ix is just equal to 2 volts minus 64 over 7 volts divided by 10 kilo ohms over 7. Now this is becoming a little bit ugly here. So what I need to do is I need to calculate this thing in a faraway land where I have space. That gets me Ix equals to 14 volts minus 64 volts divided by 10 kilo ohms. That is minus 50 volts over 10 kilo ohms. That is equal to minus 5 milliamp. Now let's see what was our previous answer. Minus 5 milliamps. Took a little longer